So this is the second part of our lesson on powers and exponential expressions. We're going to look at two things. First, we're going to look at what you do if you have an exponent of 0, and then what you do if you have a negative exponent. So 0 exponents are pretty easy. Anything to the exponent 0 is equal to 1. So if I've got x to the exponent 0, that is equal to 1. Okay? If I've got negative 3a squared b to the power of 5 to the exponent 0, the 0 exponent applies to all of that stuff in the base, all that stuff in the brackets. This is just going to equal 1. So this, we can kind of combine these with the exponent rules that we've been learning up until now. So if I've got 3 to the 3 divided by 3 to the 3, I know I'm going to keep the base. I'm going to subtract the exponents, 3 minus 3. That gets me 3 to the 0, and 3 to the 0 is just going to be 1. And this makes complete sense, right? Because if I were to do this a different way, and I were to put 3 to the 3 into my calculator, I would get 27 in the numerator, I would get 27 in the denominator, and I know that anything divided by itself is just equal to 1. Okay, so this is why anything to the exponent 0 kind of has to be equal to 1. It's like we're dividing it by itself. The only thing to be aware of is something like this, where I've got 23 times x squared y to the negative 4 to the power of 0. Remember, we have to use order of operations. So that 23 is multiplied by the stuff in the brackets. So we have to do the multiplication second. We do the exponent first. Everything in brackets to the exponent 0 is just going to be 1. So this is going to be 23. Okay? 0 exponents, pretty straightforward. Now, negative exponents are a bit trickier. So I just want to show you what it would look like to work with a negative exponent first. I'll give you the answer first, and then we'll explain sort of why it's correct. Okay? So what is 2 to the negative 3? 2 to the negative 3 is actually equal to 1 over 2 to the exponent 3, or 1 over 8. Now, how can we see that this is correct, or have confidence when I tell you this? Let's look at a little expression like this: 2 to the 3 times 2 to the negative 3. If we apply the exponent rules that we've just been looking at, 2 to the 3 times 2 to the negative 3, we're going to keep the base. We're going to add our exponents to get an exponent of 0. So this has to equal 1. 2 times 2 to the exponent 3 times 2 to the negative 3 must equal 1. Well, let's say we didn't know what 2 to the negative 3 was equal to. Okay? And let's just replace 2 to the negative 3 with some variable, like y. So let's say we had an equation, 2 to the exponent 3 times y equals 1. How did we solve this? Well, we would probably do the order of operations. We would apply the exponent first. So 2 to the exponent 3 is 8. So 8y is equal to 1. And then we would solve for y. Y equals 1 over 8. Okay? So this is sort of telling us that this thing that we said was equal to y, this 2 to the negative 3, 2 to the negative 3, must equal 1 over 8. Okay? So that's kind of why it works. All right? Let's look at how you would sort of simplify these expressions in practice. Okay? So if we've got a negative exponent like 2 to the negative 3, what I would do is I would think of that base of 2, as a fraction. 2 over 1 to the power of negative 3. And the negative kind of just means we're going to flip that fraction over to 1 over 2. And when we do that, we can change our exponent from positive to negative. Okay? Flip it over, change the sign. Then we've got negative 1 over 2 to the power of 3. That exponent of 3 applies to both the numerator and the denominator. So we're going to get 1 over 2 to the 3, which is just 1 over 8. And we don't have to write out these steps every single time. Okay? So we've got our next one here, negative 7 to the negative power of negative 2. I'm going to think of that as negative 7 over 1 to the power of negative 2, and then I'm going to flip it over, and I'm going to change that exponent to positive 2 and move it down. Okay. Now, the 1 is also to the exponent 2, but 1 to the power of 2 is just going to be 1. So this is going to be 1 over 49. Okay. So we can get pretty quick at this. 3 to the exponent of negative 3 is going to be, well, flip it over, so it's going to be 1 over 3. Apply the exponent, 1 over 27. Okay. We can do this in conjunction with our exponent, our other exponent rules. X to the 3 divided by x to the 5, we know we're going to subtract the exponents, x to the negative 2, and now we know what to do with that negative exponent. It's going to be 1 over x to a positive exponent of 2. Where the fraction thing becomes kind of important is if you've got something that is already a fractional base, something like 2 to the 5 to the negative 2. There, you want to say, okay, the negative exponent means flip the fraction over, 5 over 2 to the exponent of 2. And then like we talked about, apply that exponent of 2 to both the numerator, 5 to the 2, and the denominator, 2 to the 2. So 25 over 4. This last one's a little bit tricky because we've got the exponent is just up in the numerator there. I would take something like this, and instead of thinking of it as x to the negative 7 divided by 6, I would think of it as x to the negative 7 times 1 over 6. Okay? We know what to do with the x to the negative 7. We know that's going to be 1 over x to the 7, so times negative 6. And then we can just multiply these two fractions. Multiply the numerators to get 1, multiply the denominators, 6x to the 7. So that's negative exponents.